Okay, the first thing that you're going to do is transcription. All right, so transcription is when you go from DNA to mRNA, and translation is over here, is where you take that mRNA and you make it into a protein. Translation happens in the cytoplasm on a ribosome. Transcription happens in the nucleus. So you're transcribing a gene. Genes are found on chromosomes. The chromosome for oxytocin is number 20. The gene is found at the top of chromosome pair number 20 for both mom and dad. They both provide a copy. So the first thing that your video Timelapse is going to show is zooming in on chromosome 20 and putting a line at the top to show that's where oxytocin gene is found. Now, a gene is nothing more than a series of ATCGs. Okay, so it's always going to be told to you which side of DNA you will use. And it's usually going to be the one that says it has the promoter on it. So the first thing that happens is RNA polymerase binds to the promoter, and it goes down the gene and it transcribes the gene till it reaches the termination sequence. So what you're going to do, again, is you are going to transcribe this gene. This is codon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They match all across there. So you're going to transcribe this gene. You're going to use this bottom gene because that's where the promoter is. Transcribe it, and then for maybe a cool special effect, actually this is not a special effect compared to what you guys are used to, but you could roll it up like a snail, and as it zooms down, it can unfold like that. Okay, now that it's done, it's ready to leave the nucleus and attach to the ribosome to begin the process of translating that code into a polypeptide made of amino acids. So for this, you're going to have to make a modification with your new mat. You're going to have to cut a hole big enough for this strip to go in. You might even want to cut your strip down a little bit to fit, so it's not like crazy large. It takes up the whole ribosome. You don't need RNA polymerase anymore. Off there, and then go like that. You could even just make it a strip like that. Okay. Then you can feed it in there like that. There we go. Do that instead. Okay, start with codon 1, and then watch the next video. It will tell you how to do this specifically. Okay, this tutorial is going to show you how to do the translation part of making a protein. So at this point, you have all 9 of these tRNAs created with your anticodon and your correct amino acid letter B secured on there with Play-Doh. And I recommend putting them in order 1, 2, 3, 4, 5, 6, 7, 8, 9. The final one is number 10, which is your stop codon, which I made that one for you. You don't need any beads, you just need anticodon, which is also on there. Okay, so you put your your mRNA through, this right here is the ribosome. You put it right there, and you find the correct tRNA that matches it with anticodon because they're attracted to each other. So this is going to bring in this tRNA, which then brings that amino acid on to the growing polypeptide. So you take the bead and you start creating a chain, right? This one goes away, gets refilled with amino acid from someone's diet. You pull this through, AAA. It's going to have the anticodon UUU. That's a matcher. You're going to pull in that amino acid, remove it, add it to the growing polypeptide chain like that. You can space them out a little bit because there's bonds between the two. That goes to get refilled, and then the next one comes in, GGG. I look for the one with anticodon CCC, clicked and connected. This amino acid is added into the growing polypeptide like that. And you're doing all this with a time-lapse video until you get through all of your amino acids. I have one more on here for the demonstration. Anticodon, remove, connect, right there. Okay, and then the only thing that's unique, you'll go all the way through 10. This one just goes through 1, 2, 3, 4, 5. UAA pulls in the stop codon AUU. That stop codon releases everything. Everything falls apart. This is now ready to be folded and transported to the body.